Okay, good day everyone. So today, I will going to discuss chapter 4 with you all, which is the radiation. Okay, so let me mark this first. Okay, put here. Which one is better? Okay. The introduction. Unlike conduction and convection, radiation does not require the presence of a material medium to take place. Okay, as you can remember what we have discussed before. For a conduction or convection, it needed a medium. Okay, for conduction, the medium is static. By where the convection, there is a movement of the medium. So compared to the radiation does not require any medium in order for the heat to be transferred. Okay, how the heat being transferred in radiation is actually by thermal radiation, where it is electromagnetic radiation emitted by a body as a result of its temperature. There are many types of electromagnetic radiation, and one of it is thermal radiation. Regardless to the type of radiation, it is propagated at the speed of light, which is the sigma equal to 3 times 10 to the power of 8 meter per second. Okay. Excited charges or changing electric currents give rise to electric and magnetic field. This rapidly moving field are called electromagnetic wave or electromagnetic radiation, and they represent the energy emitted by matter as a result of the changes in the electronic configuration of the atoms or molecules. So you can relate back what you have learned in electrical power emission, where I think we discussed very thoroughly in terms of electromagnetic. Okay, how can the electromagnetic being generated or being produced by using a transformer? Then we have coil or winding, and then we have magnetic core. So the combination between those two items, and then we have a movement. If you can recall the four fundamental of electromagnetism, so we can produce electromagnetic wave transport energy just like other wave, and they are characterized by their frequency F. This is wrong. Okay, actually it is F. Okay. Okay. F frequency or wavelength. These two properties in a medium are related by C equal to lambda F. Okay. What is actually C? C is propagation of wave in that medium, or we can say that C is a ratio between speed of light divided by the index of reflection. Okay, you can see here. Okay, the formula. Yeah, the formula here. Oh, sure. Okay, what is wrong? Never mind. Okay, so C equal to C naught divided by N. So the C is actually is easy. Just you remember that the C naught is 3 times 10 to the power of 8 meter per second, and n is the index of reflection, where it is depend what type of medium. Let's say for this is n is given as 1, the index of reflection of air, and the most gases n is equal to 1.5. N equal to 1 for air and most gases, n equal to 1.5 for gases, and n equal to 1.33 for water. It has proven useful to view electromagnetic radiation as the propagation of a collection of discrete packets of energy called photons and quanta. In this view, each proton of frequency n is considered to have an energy of E equal to hv equal to hc over lambda. The energy of a photon is inversely proportional to wavelength. So this is E here and lambda here. Not sure what is wrong. Okay, where the h is actually a constant, Planck constant, where the value is 6.6 times 10 power negative 34 joule second. Okay. The hot object in a vacuum chamber will eventually cool down and reach thermal equilibrium with its surrounding by a heat transfer mechanism, which is the radiation. So if we have a vacuum chamber, then inside it we put a hot object. So okay, the heat coming out from the hot object is by radiation, and after some time it will reach thermal equilibrium, which is the temperature in the vacuum chamber is equal to the temperature inside of the object. So that is why we call equilibrium. Radiation differs from conduction and convection in that it does not require the presence of material medium to take place. Radiation transfer occurs in solid as well as liquid and gases. So this figure here is another example of radiation. Okay, usually when we have a fire camp or campfire, so we make a fire, then during at night we stay around the fire so that we can get some heat. Okay, the heat coming from the fire is actually through radiation. Okay, radiation. Okay, thermal radiation. For engineering application concerning electromagnetic radiation covers a wide range of wavelength. So when we talk about radiation, is actually we have wide, it is depend on the frequency or the wavelength. Of particular interest in the study of heat transfer, it is thermal radiation emitted as a result of energy transition of molecular atoms and electrons of a substance. Thermal radiation is defined as the spectrum that extends from 0.1 to 100 micrometer. So here we have a lot of wavelength. Okay, so different type of different stages, different type of wavelength. So the largest one is of course electrical wave. The wavelength is likely 10 to the power of 10 micrometer. So where is it? The thermal radiation is here. Here. So for radiation to happen, the wavelength is some this range. So this is X-ray, gamma ray, and so on. So this is this thermal radiation, the range of thermal radiation. Radiation is volumetric phenomenon. However, frequently it is more convenient to treat it as a surface phenomenon. The type of electromagnetic radiation that is pertinent to heat transfer is the thermal radiation emitted as a result of energy transition of molecules, atoms, and electrons of a substance. Temperature is a measure of the strength of this activity at a microscopic level, and the rate of thermal radiation emission increases with increasing temperature. Thermal radiation is continuously emitted by all matter whose temperature is above absolute zero. So this is just a basic definition of temperature, where actually we temperature is a measurement of strength of the energy transition of molecules. Light is a simply the visible portion of the electromagnetic spectrum when that lies between 0.4 and 0.76 micrometer. So the wavelength in table, in this table here, based on the wavelength, so we have a different color. So different color, we have a different wavelength. A body that emits some radiation in the visible range is called light source. So radiation that are visible, we can see through our eyes, we call as light source. So the sun is our primary light source. The electromagnetic radiation emitted by the sun is also known as solar radiation, and nearly all of it falls into the wavelength band of 0.3 to 3 micrometer. Almost half of solar radiation is light, which fall into the visible range, with the remaining being ultraviolet and infrared. So which means that solar radiation have three components. The first one is light, which we can see by our eyes. Second one is ultraviolet, lastly infrared. So okay, we know that the half, almost half of solar radiation is light.